This is Jenny Kunkel, and in this video we're going to take a problem and work it from logical through physical design. In this case, we're going to be starting out with a puppy trick unnormalized relation, and this is going to have a repeating group of trick, and that's going to be keyed by the trick ID. We also have the puppy relation that's going to be keyed by the puppy no. And in order to get to first normal form, we need to concatenate the primary key of the puppy relation, which is puppy no, with the primary key of the trick repeating group, which is trick ID. Once we do that, we should be at first normal form as we have documented here. In order to get to second normal form, we need to remove partial dependencies. And what that means is currently we have a primary key of puppy no and trick ID. If we have any fields that are dependent on just a portion of the key, either the puppy no or the trick ID, then we need to remove those into separate entities. If we look at our fields, we have puppy no, and that is going to functionally determine puppy name, kennel code, kennel name, and kennel location. So we're going to need to remove and create a puppy relation that has some of that information. Essentially the puppy no, puppy name, kennel code, kennel name, and kennel location. Then for our trick ID, that's functionally determined just the trick name. So we're going to need to remove that to a separate entity as well. We're going to be left with our puppy trick, which is going to contain our puppy no and trick ID. That concatenated key is going to functionally determine the trick where learned and the skill level. So at second normal form, we see that we have our functional dependencies, pretty much how we stated them above, documented, as well as our entities with their primary keys located, but we also are going to document the foreign key relations. So where we have our puppy no that is going to be referenced from that parent table puppy, we need to have that foreign key association documented because that will play into what we need to create for our tables. We also have our trick ID, which is going to have a parent table of the trick. So we're going to implement one-to-many relationships between the puppy and the puppy trick table and the trick and the puppy trick table as we create our actual tables. Going to third normal form, we need to remove any transitive dependencies. And if we look at our puppy, we have transitive dependency between our kennel code, kennel name, and kennel location. Our kennel name and our kennel location really just depend on our kennel code. So we need to factor these into a separate relation that's going to leave us with a dependency for our puppy no of puppy name and kennel code. And then we're going to have a dependency from kennel code to kennel name and kennel location for our third normal form. And then we're going to have a kennel entity that we're creating, and it's going to be keyed by the kennel code. It's going to also implement a foreign key relationship off of the puppy to our new kennel relation. So if we go to third normal form, we should see that we have everything documented. We can see that we have the puppy no trick ID with the trick where learned and skill level, the trick ID with the trick name, the kennel code to the kennel name and kennel location, the puppy no to the puppy name and kennel code. Then we have our entities down here. Each one is going to be keyed by the associated primary key. We have our new foreign key relationship that was introduced at third normal form that's going to be pointing to our kennel from our puppy relation. Everything else pretty much has been unchanged, except for some reason I haven't underlined the puppy no there. It should be underlined. Then we can draw our rough entity diagram. This gives us a little bit of an idea. We can see sort of the relations between it. And at this point, we are ready to start working on defining our physical database implementation, and we're going to generate the DDL for this. So we're going to start and put everything within a pet DB. So we're going to create the database, and then we're going to add the tables and step through everything here. Switching to SQL Server, we're going to create a new query window. And in this case, we're going to go ahead and add in the database creation statement for our pet DB. And then after we create the database, we're going to turn around and use that database. So everything that we add is going to be executed from within that instance of that database. So if we execute that, that's going to set that. Then the next thing we want to do is we have our puppy. Let's go ahead and save that because we have a foreign key on it. And we're going to create our kennel. That's going to be the next table that we create because that's going to be a parent table as well as our trick. That's going to be a parent table as well. Our puppy is, but it has the dependency on the kennel. So let's go ahead and create that kennel. If I paste in the code here for this, essentially we're going to create that table kennel. We're going to use an identity for the kennel code. It's going to have a kennel name and a kennel location. We have our primary key that's essentially going to be on that kennel code. And we can go ahead and execute this to create that. We also want to add our drop statement for this table. So let's go ahead and do that. If exists, and this is going to be on kennel. Then we're going to go ahead and add in our trick table. And I do want to put a go here as well. So if I paste in the trick table, I'm going to go ahead and execute this. I want to make sure that I go ahead and add the trick drop statement as well. Then after I get done with that, I'm going to go ahead and define my puppy, because I need to have my puppy defined before I can go ahead and do the puppy trick. So if I copy this in and paste it in, we are going to have our puppy know using an identity. We have our puppy name. Our kennel code is going to be nullable, meaning that we may or may not have one. And we are going to set up a constraint on our puppy. So this is going to be the primary key, and then we're going to have a foreign key association to our kennel code, and then that's going to be referencing the parent kennel table on its kennel code field as well. And after I execute this, I'm going to go ahead and add the drop statement there. And for our puppy, because of the fact that it has a dependency on kennel, we have to execute the drop statement before the kennel table. So I'm going to place that there. And then we're going to go ahead and go down and define our last table. And this is going to be our puppy trick. And we have our puppy know trick ID that are going to be our primary key. We can see that it's defined as a constraint with that concatenated key. We have our trick where learn. We're setting that to 40 and the skill level equal to a length of 20 varchar. We have our foreign key for our puppy trick. That's going to be on our puppy know field, and that's going to reference our puppy table on the puppy know field. Then we have the foreign key for our trick ID that's going to reference the parent table trick on the trick ID field. And notice that we are using on delete cascade. And we're going to take a look. We're going to try to insert a little bit of data and then take a look at what the ramification is of using on delete cascade. I'm probably going to change one of these to not have on delete cascade just so that we can see the difference. And I think I'm going to change the last one. So I'm going to go ahead and execute this, and it's created this. And then I want to go ahead and add my drop statement for this at the very top. And that should be pretty much everything I need to do. So if I go ahead and refresh my databases, I should be able to see some of my pet DB. If I look for my tables, Give it a second to expand. I can see I have my kennel, my puppy trick, and my trick. Now I'm going to paste in some insert statements. If we execute those insert statements, everything seems to have worked fine. We're going to add some for the kennel. We're using those identity fields to populate the primary keys. We have our kennel, 2 kennels that we're adding. That worked. We're going to go ahead and add 3 dogs and execute that. Seems like we have one too many parentheses here. Let's go ahead and change this. Much better. Let's go ahead and insert that. Now we have our 3 puppies that were added. And then finally, if we add some skills, we're going to do 2 for pet 2, 1 for pet 1, and then 2 for pet 3. And if we go ahead and execute that, it's going to insert that. So now we have a little bit of data in each table. And one of the things that we want to test is if we try to delete one of the tricks, what's going to happen. And we're going to try to delete it from the parent table. So this is going to be from the dbo.trick table that we want to go ahead and maybe remove sit, which is the first trick that's defined. And I can go ahead and say where trick name is equal to sit. And if I go ahead and execute that, we can see that we have a key constraint, and it's essentially being triggered from this fact that we have records in our puppy trick table that cannot be deleted. Now, if we go ahead and work with our puppy table and try to delete our pet 3 where we have a couple different records, and this is going to be where the puppy's name is equal to Lucy. And if I go ahead and delete that, notice that I don't have any problems with that deletion. And if we look back to where we defined that foreign key on delete cascade, it essentially means that it's okay when somebody wants to delete something from that parent table, it's just going to cascade and perform all deletes at that lower level table that's referenced by that foreign key constraint. So if I would come in and try to find any records for puppy 3, I should not be able to see those. So from puppy trick, where puppy no is equal to 3, I shouldn't get any records returned to me. I can still see the records for puppy 1. I should have 2 here. No, puppy 1 had 1. Sorry, puppy 2 had 2. And if I execute that, I still have 2 records there. So just for that puppy that I deleted from the puppy table were the deletes cascaded. Now I didn't set up the trick for that to be cascaded. If I had, then I wouldn't have seen that foreign key constraint pop up with an exception there when I tried to delete it from the table. So those are just kind of getting through our physical design based off of what we had in our unnormalized relation through the end to our physical table creation, and then just playing around with that foreign key constraint by loading a little bit of data.